student, I, Soumen Sir, lecturer in mechanical engineering. Today we are going to learn to solve a problem on bending stress in beams. Problem number 1. Evaluate, that means find the maximum intensity of bending stress. Find maximum intensity of bending stress. We know maximum bending stress developed on topmost layer and bottommost layer from neutral axis. Topmost layer maximum compressive stress and bottommost layer maximum tensile stress. In this case, since the cross section is symmetrical, here maximum tensile stress and maximum compressive stress are same. Evaluate the maximum intensity of bending stress developed in a flat steel. Steel flat means cross section of steel section 50 millimeter wide and 6 millimeter thick. When it is bent around a wheel, on a wheel of 6 millimeter diameter, take ES, modulus of elasticity of steel, equal to 2 into 10 to the power 5 Newton per millimeter square. Here the wheel, this is the wheel diameter 6 meter. Around this wheel it is bent around this wheel. Here given cross section of beam, this is 50 millimeter, width is 50 millimeter B, thickness T, this is thickness T equal to 6 millimeter. When dia of the wheel around which the steel flat, steel bar is bent, diameter capital D equal to 6 meter, equal to 6000 millimeter. Also given modulus of elasticity, that means Young modulus E equal to 2 into 10 to the power 5 Newton per millimeter square. Here the radius of the wheel, diameter of the wheel D, radius of the wheel R equal to capital D by 2 equal to 6000 by 2 equal to 3000 millimeter. So radius of curvature, this is the radius of curvature, this is the neutral axis. Radius of curvature capital R equal to this length 3000 millimeter plus this is thickness T হচ্ছে 6 millimeter plus 6 by 2 equal to 3003 millimeter, capital R equal to 3003 millimeter. Here maximum distance from neutral axis y. Maximum distance from neutral axis, the topmost layer and also bottommost layer, maximum distance from neutral axis upward and downward are same. Y equal to 6 by 2 equal to 3 millimeter. Okay. Now from bending equation, F by Y equal to E by R. This is the bend around a wheel, that means in this layer maximum compressive stress and in this layer maximum tensile stress. Here both are same, value of both are same. Here F is the bending stress at a distance y, that means maximum layer, top layer or maximum bottom layer from neutral axis, and y means distance of topmost layer or bottommost layer from neutral axis. R equal to radius of curvature of neutral layer. E equal to Young modulus of beam material. Here we find out the F. F may be maximum tensile stress or maximum compressive stress. Value of Y equal to 6. This is thickness 6. So from neutral axis, Y equal to distance from neutral axis 6 by 2, 3 millimeter. Value of Y equal to 3 millimeter. E equal to 2 into 10 to the power 5 by R equal to radius of curvature 3003 millimeter. So F equal to 2 into 3 into 10 to the power 3 by 3003 equal to 199.8 Newton per millimeter square, approximately 200 Newton per millimeter square. Okay, so maximum intensity of bending stress, so maximum tensile stress or compressive stress in the steel flat equal to 200 Newton per millimeter square. This is the answer. Okay.